Stephanie?
Yep.
Stephanie,
Listen.
could I ask you a question? Okay. Would you guys be able to continue working on the test at 7:20, or do you have something else to do?
No, I can.
Oh, that's true. Then if it's okay with your classmates, they can continue working too, because I like to have people have the time they need. Then let's have you sort of wind up in the next few moments, and I'll give the test back to you at 7:20. You can work some more. How's that sound?
That's fine, I was on the last answer, so I'll finish it up later.
Okay, as you wish.
That's fine?
Yes.
You want it to do right?
Either way, I'd
Okay,
like to.
I'll just take a bathroom break, I'll finish it up after class.
That's better, yeah. That's better.
I'm gonna leave 5, 10 minutes, you want some.
Yeah, no sense feeling under pressure. There'll be plenty of time later.
Bathroom break.
Sure. So we'll take a 6-minute break, how's that?
Yep, thank you.
And I'm gonna stay with you for sure,
Oh,
right?
thank you.
Okay.
I won't need it all. I botched.
Yeah, was it the survivor indictment? That's the one.
I know for a fact I missed one.
Which book are you in?
Number 18. The one that was, what type of,
Oh, like systematic instance?
yes. Are any of the answers up for interpretation?
Yes, but I try to avoid ones that are interpretive, so I hope I succeeded. Non-ambiguous answers. I'm sorry the windows are locked for the winter, you can't jump out.
I'd be so irritated.
I know. I'll stand between you and the windows anyway. We don't want to break the window.
I don't remember what paper it's on because this one right here. Number. Okay, you can tell me because.
Read the question.
I'm trying to find the one that I'm having one.
It was with Carla
18.
and
In a study of college, this is it random? Actually, then you can point to which one. So it's this one. That one's not open for interpretation, huh? Can I have a test back?
In a week.
We need our book or we need the
No,
handout?
you don't need anything. I'll give you everything you need right now. 2 more minutes.
oh, are the tests different?
Hmm?
Like each test is different?
Everybody's students? No, most students have the same test.
Same exact problems?
Yes.
I don't remember
Right.
seeing this one.
One thing we need to do is to brush the erasures off your desk. We get serious complaints from the morning class if that's not done, so.
Well, this is.
We actually had a complaint the other way around. I got on that guy too.
And this is why I get this.
It wasn't you, it was the other class. We had some erasures here.
Sorry,
I remember picking that answer.
sorry,
We did
I
20
know for a fact
push-ups.
that I got one.
So 2 more minutes, free time.
You said that you got one wrong?
I know for a fact,
Sorry,
yeah,
I
at least one.
I went through and did all the problems, but that, well, I shouldn't.
Oh, yeah, you can't talk because.
I know, I'm
Yeah,
completely
two
fine.
people still
I'll be
left.
quiet.
Yeah, so we can't talk specifics.
I'm
No
done.
specifics, except for the fact that I'm probably going to cry myself to sleep tonight. You know what, it's because I didn't stress, babe.
I like
You
that
can
help.
save your tissue and just give me back my paper.
We got what, 6 more tests, right?
No, 3 more tests.
3 more tests.
Oh, 3 more tests.
3 more tests.
Just add the pressure. It's good.
3 more tests. Well, you can wear the t-shirt now. I took a stat test. People, oh, wow.
In the back of it
It
says
really
my
wasn't
favorite.
bad for me with the last 2 problems right now.
I'm still alive, but my grade is not.
Well, there goes my GPA.
Yeah, I just wanna pass this class. That's a
You
big deal
two
for
were
me.
laughing, you probably got an
I
A.
stuck it in.
That was a joke.
You guys
Always
probably got
have.
an A. Yeah, laughing.
Oh, still 60 seconds of random talk, which is this,
Keep talking.
clock keeps ticking.
What's the last university in the States you actually taught, like a major university in stateside that you taught at? Just curious.
Well, I don't know what you mean by a major one. I've never really taught at a major university. They were legitimately universities, like Central Texas University, was I doing any teaching there? No, just as a graduate student. Central Michigan University, I guess, is the only one that really has university after.
That's not Ann Arbor, is it? Is it Ann
No,
Arbor?
no, it's a smaller one, Kalamazoo,
Okay.
yeah. And I taught at a college and 3 or 4 community colleges as well.
But they love you.
Hmm?
Said I bet they love
Well,
you.
Well, community college, you have like grown people there, you got a whole mix.
Just like here, we have adults coming in at nighttime,
Night classes.
but we had a sprinkling of spoiled 17-year-olds just to keep things messed up. No, they didn't love me any more than you guys did, because I don't feel happy if there's not execution, accomplishment, things get done, so no giveaways. But it was okay, we had a pretty good relationship. Yeah. So, yeah.
You mentioned computer coding, where did you?
Pardon me, ma'am?
You mentioned computer coding?
You wrote computer code.
Yeah, I've done that for a living.
Wow.
Like, 312 years ago, I got a letter from the President of the United States inviting me to spend a few years in the military. It's called the draft, offer you can't refuse. So I accepted. And inside the military, they taught me how to program computers, which totally disgusted me because I like theoretical physics. But for the next 92 years of my life, I was able to turn $1 anytime I wanted to by computer programming. So I ended up with about 412 years experience. So Maryland lets me teach computer courses. I also have my own company. That's why I'm teaching.
You look excellent for your age.
I'm only 37, come on.
If you're 37, I'm 6.
You look 7.
Vietnam vet.
Okay, so here's our new assignment. And tonight's assignment is A5, and we'll get to do some percentage of it. But the biggie, and here's your material for the next 2 classes, this class and Saturday's class. So, I need to tell you that we do have class on Saturday. Okay. Now, this material I just passed out to you is 4 sections, 4 more sections of probability. It's the rest of probability. Sections 5, 6, 7 and 8. We'll do sections 6 and 7 tonight, because they're a little bit easier. And the more complex ones, or 5 and 8, we'll do those on Saturday. Plus on Saturday, we'll do whatever we don't get to do tonight, because the clock ticks and we ran out of time. But by close of business on Saturday, we will have finished probability. We will have finished these 4 sections. Which means that for that long weekend that you have until next Tuesday, you'll be in good shape. And these tapes will be spinning, they'll be out there to help you. As mentioned, go to YouTube. YouTube has full set of very, very good little short clip videos on all of these topics by other instructors. So go there and find a personality that suits you, Khan Academy or anybody else, and get different slants and the same stuff. So use resources, all right? So, what I'm gonna do then for the next half hour or so is present as much as section 11.6 and 11.7 as time permits. So, section 11.6, if you'll turn to the first page in the handout, section 11.6, you'll see it has a title called Events Involving Not or Probability and Odds. I'll present odds last because it's a standalone topic, nothing builds on it. It's cute, especially if you gamble, but it's less demanding for the rest of the course than the others. So I'll put that on the list for last. And not probability is very easy, because if the probability that it's going to snow tomorrow is 85%, the probability it's not going to snow is 15%. So the probability of not A equals 1 minus the probability of A. Now the next one is a little bit slower, and it looks like this. The probability of at least once equals 1 minus the probability of none. And I'll illustrate that to you. If the probability that Stephanie will never go to London in her life is 60%, if the probability that Stephanie will never go to London in her life is 60%, then what's the probability that she will go at least once? 40%. Now, it's the same probability that she goes twice or 3 times, agreed? Because as soon as she goes at least once, she can no longer say she never went, agreed? So the probability of at least once is the opposite of the probability of never. This applies to certain things in life, and I'm not going to go there. But suppose, for example, you've never told a lie. But as soon as you tell your first lie, you can no longer say you never told a lie, agreed? So the probability of at least once is 1 minus the probability of never. They're opposites. The next is, if I take this deck of cards, and I want to know the probability of drawing a 6. What's the probability of drawing a 6? 4 over 52. What's the probability of drawing an 8? 4 over 52. Now, what's the probability of drawing either a 6 or an 8?
8 or 50.
Now, it obeys a fundamental rule, which I hope I've mentioned before. It's the number of favorable cases over the number of total cases. And you can do this probability of a 6 or 8. This is called OR probability, and in general it's a probability of getting A or B. 2 different outcomes for the same event. Now, looking at it simply and using this formula, it's 8 over 52, agreed? But you see, you can arrive at it in 2 steps. It's either the probability of getting a 6, which is what? 4 over 52, plus the probability of getting an 8, which is another 4 over 52, agreed? So you can say that the probability of A or B, you can do in 1 step by counting up the number of favorable cases that are favorable to I, or you can do the 2 probabilities separately and then add them together. And this is the formula for 2 events, 2 outcomes from the same event. 1 event with 2 possible outcomes, you can calculate the probability separately and add them together if you prefer to do that. So this is known as the OR rule, and I don't like rules. I would not show it to you, except that's obligatory to show it to you in a course. I really like you to count up the number of favorable cases, count up the number of total cases, but some students prefer to use rules. Now this rule has a certain qualification. For example, if I take my die and I ask, what's the probability of getting an odd number or a number greater than 3? Now, according to the rule that the probability of A or B can be expressed as the probability of A plus the probability of B, then this would be the probability of odd plus the probability of greater than 3. Now, what's the probability of an odd number? 1/2. Now, what's the probability of a number greater than 3? So you see, we get 1 for this, which we know is wrong. Because if we simply count in our sample space, which is basically what probability is, then let's count the favorable cases. Is 1 favorable? Because it's odd. Is 2 favorable?
No.
3 is favorable because it's odd, and the rest are greater than 3, so they're all odd. So by doing probability in terms of what it really is, counting, we know that the answer is 5/6. So this formula is not complete. And the reason it's not complete is because of double counting. There was one number that we counted twice. We counted it once as an odd number, and we counted it again as a number greater than 3. And which number was that? 5. So you see, this formula is not complete because there are some cases that are counted both here and here. That is, they're counted twice. And that's once too many. So to make the formula complete, we have to subtract off those cases that were counted twice. So those cases for which it's true that they both satisfy A and B, they were counted here once and here again, so we have to subtract off one of those countings. One of those countings has to be subtracted off. Now in this particular example, the probability of odd was 1/2, but now we have to subtract off the probability of odd and greater than 3. Now, how many cases were simultaneously and at the same time both odd and greater than 3? 1. So we have to subtract off 1/6. And then we get the correct answer, 5/6. So the complete rule for probability is that the probability of A or B, now this is one event, one die, one event, one draw of the card with two different outcomes, is equal to the probability of A alone plus the probability of B alone minus the probability of anything that was both A and B. Why do we have to subtract off the probability of anything that was both A and B? Yeah, it was counted once as A and once again as B. Now I'm going to go to a different type of probability. This probability that we've studied so far is one event, two outcomes. Now I'm going to study a probability which is two separate events. One follows the other. Two events. I'll give you an example. This is a coin. What's the probability I'm going to flip this coin, get a head, and then I'm going to roll this die and get a 3? Two events, agreed? What's the probability that's both going to happen? Okay, I'm going to show you how to make this calculation by leading you through a real-life example. You get up in the morning and you drive into your job. And 1/4 of the days, when you arrive at work, your supervisor says, "We don't need you today, go back home." You're glad you're sitting down so you don't fall down. So one day in 4, your supervisor says, "We don't need you today, go back home." 1/4 of the time, agreed? Now, when you get back home, half the time, your family is out, and you get to take a nap. The other half the time, you don't get to take a nap, true? So my question to you is, as you drive into work in the morning, what's the probability that you're going to get to take a nap?
1/4 plus 1/2.
1/4 plus 1/4. Yeah,
Plus 1/4.
that's a good first stab. Anybody want to say anything else?
1/2 divided by 1. Or
1/2.
1/4 divided by 1/2.
1/4 divided by 1/2. Anybody want to say anything else? We've still got minus and times left, so. Okay, so now, she knows. So let me tell it to you with a bit emphasis and hints to sort of give it away. 1/4 of the time, you're going to go back home, agreed? Of that 1/4 of the time, half of those 1/4 you're going to get to sleep. So half of the 1/4 times you get to go home, you're going to get to sleep. So my question is to you, what is 1/2 of 1/4? 1/8. Because 1/4 is 2/8, isn't it? And half of that would be 1/8. So in order to get that, you have to take the probability of the first, 1/4, and multiply it by the probability of the second. One fraction times another. So you take the 1/4 and multiply it by the 1/2, and you get the 1/8. Because 1/2 of the time you get home, you get to take a nap, but you only get home 1/4 of the times. So what is 1/2 of the times of 1/4 of the times? In math, the word of always means multiply. So let's come back to this coin toss and die. Now, I'm gonna toss the coin. If it's not a head, I don't get to go to step 2. Game over. So half the time the game is over, right? But half the times I get to go to step 2. Now, of those half the times that I get to go to step 2, what's the probability I'm gonna get a 3 on top? So what's the probability I'm gonna accomplish both tasks? 1/12. That's right, 1/2 times 1/12. So in this scenario, where you have the probability of A and B, where one follows the other. Now remember, these are two events. It's equal to the probability of A times the probability of B. So let's work with that with the deck of cards. What's the probability I'm going to draw this card and have it be an ace, and then put it back in the deck and draw another card and have that card be an ace too? What's the probability of getting 2 aces in a row with replacement? We call it probability of 2 aces with replacement. Well, what's the probability that this card is an ace, the first one? 4/52, agreed? Now, if I don't win that one, I don't get to go to step 2, game over. But if this is an ace, I get to continue. So 4/52 of the time I get to continue. And by continuing, I replace this, and now I draw another card, and now what's the probability that this card is an ace? 4/52 again. So what's the probability of 2 aces in a row? 4/52 times 4/52, agreed? Now, this is sometimes different, because now I'm going to ask you, what's the probability of 2 aces without replacement? Who said that? Not bad. So let's take it in steps. What's the probability that this card is an ace? If it's not an ace, I don't get to proceed, do I? Game over. But 4/52 of the times, I get to go to step 2. Now notice what I do. This is an ace. Boom. Now, what's the probability my next card is an ace? 3/51, agreed? Did you, Kaylee said 3/51? 3/51. I should have told you this before, but the probability of A is the number of favorable cases over the number of total cases. This is important. I don't see how I can not mention it. So at this point, how many total cases are there? 51 at this point, agreed? At this point, how many are favorable to being an ace? 3. So the probability at this time of drawing an ace is 3/51.
Because you drew one out.
I sure did,
Yeah,
it's
we
right
don't
there.
think so, that's why.
That's right. Now, what's the probability of drawing 4 aces without replacement? Well, the first one is 4/52. What's the next one?
3/51.
And the next one?
2/50.
And the next one?
1/49.
4 aces without replacement. Right? Now, what's the probability of drawing 5 aces without replacement? Not gonna happen. Not gonna happen. Now, do we know enough to answer a very, very difficult problem that you would not have been able to answer 20 minutes ago. So you're gonna see how much you have increased your respectability in 20 minutes. Okay, your phone rings, and it's a friend of yours that you haven't heard from in a number of years. He's now selling real estate in South Florida. And he says, I have a customer across the desk. He's all set to buy this big expensive mansion. But before he signed, he asked me one question. He said, what's the probability of at least one major hurricane in South Florida over the next 10 years? What's the probability of at least one major hurricane in South Florida over the next 10 years? And he says, I know that you took Math 103, so I know you're going to be able to give me that number. And you said, I'll call you back in 5 minutes. Okay, you hang up. So what's the first thing that you do?
You need to find out how many hurricanes happened in the past.
That's right. You need to go to the history books and you get to get the percentage of the past, agreed? So let's take an arbitrary number of years that you go back. Suppose that you search the last 19 years. And in the last 19 years, there were 5 major hurricanes. Okay? 5 years with major hurricanes. So with that, knowing that the percentage of the past is the probability of the future, then please tell me, what's the probability that South Florida will be hit by a major hurricane this next year? Just as a fraction. The fraction would be a fraction of this year is equal to 5 over 19, agreed? The percentage of the past is the probability of the future. Okay, now, what's the probability that it will be hit this year and next year? Now, this is like drawing 2 aces in a row. If you're not hit this year, you don't get to go to step 2. So what's the probability that it gets hit this year? 5 over 19. If you get that far, then what's the probability that it's also hit next year? No, because this history data
6 over 20.
is fixed. Yeah, it would be, but we're not going to increase our data pool. We're still going to just look at these 19 years, okay? So it's another 5 over 19. Good. Now, what's the probability that it's going to be hit 5 years in a row? 5 over 19 to what power? 5 power, right? 5 years in a row. And now, what's the probability of no major hurricane this year?
14 over 19?
Yeah, who said it? Was that Stephanie?
No.
No major hurricane this year is 14 over 19. So Freddie, how did I get that number? Did I pull it out of my rectal database or?
You took the leftover.
I took the leftover. That's, it's never been called the leftover before, but that's exactly what it is. It's a leftover.